Materials used in flying saucers. Abstract. Germanium-75 and element 115 found in UFOs, in EFOs actually, identified flying objects. There are two known cases when people put their hands on the materials from flying saucers. 1. In Bob Lazar's story about 9 such crafts parked in Area 51, of which engine reverse engineering Bob worked on. 2. Roswell 1947 UFO crash. In short, in the case described by Bob Lazar, input/fuel is element 115, and output is slow time around the craft and fast time around the core/reactor. For details, check my book. Neither heat nor electromagnetic output has been detected by Bob Lazar's team, U2.B. Bob does not know whether the craft body was ceramic or metallic. Materials team worked on that, and Bob had no direct interaction with them, but he noticed that one archway became transparent sometime. Bob refers to the smart glass analogy. Some natural and some artificial materials become transparent under heat or electromagnetic treatment. But this craft/engine produced neither heat nor electromagnetism. All it was doing is changing flow of time around the craft. Time dilation is the official term for time slowing down, and accelerating it around the core. That leads us to the materials like germanium. Germanium lets light in the wavelengths of 8,000 to 14,000 nanometers, the infrared, spectrum to pass through and blocks all other light, including visible light, which has 380 to 700 nanometers wavelength. Germanium is a metalloid, shares metallic and ceramic properties, similar in appearance to silicon, which is a more abundant metalloid used everywhere. And there are other materials, alloys, salts, that are opaque except for certain light wavelength ranges. Let's stick to germanium and figure out how it can become transparent when time treated. There is 20-fold, 20 times, difference between 380 to 700 nanometers visible light spectrum and 8,000 to 14,000 nanometers light spectrum for which germanium is transparent. We already solved a similar problem for Bob Lazar's frozen candle. Let's do it again now for a germanium wall. Even with an additional layer of slower time around the craft. A similar solution still works with additional multiplications and divisions on wavelength. In total, it all cancels out. Similar to what was explained in the frozen candle solution, look for the below image in that article, and the explanation below it. Total wavelength change from the beginning to the end depends on two factors actually. Time speed at the beginning, where light comes or reflects from, and time speed at the end, which is time where observer's eyes are. And both times are the same, normal for us time speed, turning into infrared on its path through the archway, due to time speed change, explained by the picture in the archway light is redshifted, allows this light to pass through germanium-like wall. And then, infrared light turns back into visible, because time changes back from sped up in the archway to normal in / around the observer's eyes. That solves the problem. Exactly that happens in the video below. The YouTuber presents germanium piece on the left, then he uses an infrared camera to record how he can see a cat through this germanium piece. Infrared image of the cat passes through germanium, and the camera converts it to the light we can see. Up until now, we have discussed regular/stable isotopes of germanium. Our topic changes from now on. I decided to Google germanium UFO, to see if there are such findings. The only article I found was objournal.com in 1997, 50 years after the Roswell crash. San Diego chemist Russell Vernon Clark made isotope analysis of the material from that crash. It was 99% silicon, and the rest 1% was split between 2 to 3 elements, one of which was germanium-75. Here comes the puzzle in his report. Vernon Clark's claim that the alleged 50-year-old spacecraft debris contained a detectable amount of the element germanium-75, a substance so radioactive scientists say it would decay into other elements in less than a day. I double-checked germanium-75 half-life. It is about an hour, 83 minutes, to be precise, meaning that in 24 hours, by the end of a day, it will remain 2-21 1/millionth. 1/millionth fraction of the original material from the beginning of the day. And after 50 years, which equal to 365 times 50 equals 18,250 days, for Vernon Clark analysis in 1997, it would have remained 1/100 billion 18,250 equals 10 minus 6 18,250 10 minus 100,000. Fraction of the original germanium-75 amount from the crash in 1947. Now, germanium-75 atomic weight, 75 atomic units, translates into 75 times 1.66 times 10 minus 27 kilograms equals 124.5 times 10 minus 27 kilograms equals 1.245 times 10 minus 28 ton. To have even one germanium-75 atom remained after 50 years, the initial amount of it should have been 10,100,000 times 1.245 times 10 minus 28 ton 1,099,972 tons, which outweighs the visible by James Webb universe. That means 0 atoms of germanium-75 should have been detected by Vernon Clark. Somehow, highly radioactive, with 83-minute half-life, germanium-75 survived 50 years. Somehow stable element 115 is used in Bob Lazar's craft, despite known 115 isotopes half-life is less than a second. For element 115, Bob Lazar suggested that some quantity of neutrons can stabilize it, meaning there might be another stable synthetic isotope than unstable moscovium. I suggested another solution. Atomic time/clock in stable element 115 atoms is extremely slow compared to our time. That would explain the astronomical amount of energy canned in this fuel as well. You can find details on this in my article Bob Lazar, element 115. Any isotope of germanium has to have 32 protons. Germanium-75 means the total number of protons and neutrons equals 75. Thus, the number of neurons of germanium-75 has to be 75 to 32 equals 43, so we cannot stabilize germanium-75 by changing its number of neutrons. So far, only atomic clock/time dilation can explain germanium-75 presence in the Vernon Clark's report. Thus, extreme atomic time dilation solves both element 115 and germanium-75 puzzles in such crafts. That means time when/where these atoms were created was very slow. Continued at extraordinary stabilizing power of time dilation, where we show that slowing down an atomic clock 100 times extends the atomic lifetime 10 billion times, and 1,000-fold slower atomic clock extends life of the atoms 1,000 trillion times. For germanium-75 100-fold clock/time dilation changes its 83-minute half-life to 1.5 thousand years. For element 115, 1000-fold clock/time dilation changes 0.65 second half-life, known for the synthetic isotope of element 115, which is called moscovium, to 20 million years.